Greetings everyone, Free here. Welcome to the Demo Hub. And to this demo, we're going to take a look at Snowflake Dynamic. As always, our links to this will be in the description below. Now, what are dynamic tables? Dynamic tables are a declarative way of processing real-time, high-velocity, ever-changing data in your Snowflake platform. Declaratively, you declare the results of what you want in your end table, and dynamic table takes care of declaratively keeping that up to date based on changes from upstream. Visually, this is what it looks like. Customer data coming in with opportunities. You want to enrich that data as the customer data changes, do some aggregations, some filtering, and end up with your clean data for reporting downstream. With a result like this that requires changes and always keeping up to date with a certain latency or a certain lag, dynamic tables is going to be the answer for you. That said, that the tutorial is very detailed. Check this link, follow along if you want to. Again, links to this will be in the description below. Now, for this exercise, we're going to be leveraging, as with every exercise, the Sales DB model. There are a couple of models that are available. Sales DB is going to be the model for this. Click on Sales DB. If you don't have that model set up, we're going to have to set up that model as the prerequisite for this. Go over to worksheet. I'll create a new worksheet, a SQL worksheet for the Sales DB. When I come in copy over, we're creating a Sales DB database. I'm assuming you're doing this for the very first time. This is a database and a schema to hold that. Next, create the objects for the Sales DB. If you're following along with these tutorials for the very first time, this is something that you do it once and you are done. Refresh. We now have our Sales DB with a schema called cost, and we have a customer, opportunities, client, and buyers. Next, insert some data. This is the first time we're inserting data into those objects from a sample data perspective. Execute that. This should insert data into that table. Now, it's described what the data looks like. Interestingly, there is still data, missing contract values, duplicate records. There's a lot of things happening with the data set we are inserting into our Sales DB table. That is done. Take a look back at this. We should have a customer table fully populated, and you can preview that. We now have customers, and all the data quality issues we saw apply. Go back to the Snowflake Dynamic Table script. For this exercise, what we need is the customers and the opportunities. Go in and see how to create a dynamic table based on the customer information. For creating a dynamic table, you do a create or replace with a decorator that says this is a dynamic table. There are different table types in Snowflake, but what's of interest is the dynamic table. Customer, enriched customer. Typically, if you think about the CRM system, you want to have very enriched customer records. Table name is enriched customer, and the lag. This is important. How often should your dynamic table refresh? Because it's a declarative way of processing. You need to keep this updated based on your base table. In this case, I'm going to do 1 minute for now. Select your data warehouse. This is the warehouse used for the refresh. And here is your select statement. Based on this select statement that has your business logic, it's going to keep this dynamic table up to date, right? In real time. Every minute it's going to process. It queries your base table, applies your business logic, and keeps your dynamic table up to date and materializes the result into your dynamic table. Super flexible. What does this logic entail for us in this case? We're looking at the base customer table, trimming emails, changing the capitalization for first name, last name, basic transformations, but you probably have more complex business logic you might want to capture in your dynamic table. And then also we are checking if the emails are valid. Imagine you're running an email campaign and you have some logic to check if you have valid emails. You're not spending money sending out emails to invalid addresses. Here is a dynamic table we're going to create. Now, before I run this, open this up, take a look at Sales DB. And if you take a look at the schema, well, look at customer schema, we have just tables, right? There's no dynamic tables. Let me go back to another view, open one more tab. If I go back to the object browser on the tab and we search for Sales DB, which we created, again, look at customer schema, look at tables, we have the regular tables. There is no object called dynamic tables. That's not visible. All right. But once we go through this exercise, we should see some changes. Going back to this, execute this script, and we should now have an enriched customer table created for us, customers table created for us that will stay up to date, looking at the base table based on the business logic we've applied. Very powerful. Now, this explains what's happening. We can even create more of those tables, create a filtered opportunities. We've created enriched customers, do the same, creating a filtered opportunities. We're looking at the opportunities table this time for as a base table where amount greater than 0. I don't know cases where amount wouldn't be greater than 0 for opportunities. Ideally, you want opportunities with amount greater than 0. And where the sales stage is not invalid, data entry issues, we want to eliminate that. And expected close date is not null. Basic checks, nothing to write home about. Create this filtered opportunities. Now we have 2 dynamic tables. I'm going to go back for a second, do a refresh. You see a new entry, which is the dynamic tables. Now you have the enriched customers and you have the filtered opportunities. Very powerful, right? These do not go on the tables. It shows up as a different entry within your cost schema. Now, if I click on enrich customers for the dynamic table, you see the table details. Like with every other tables in Snowflake, you can see the column names and the definitions of that. You can see a preview of the data. This ran already. My dynamic table is already updated with records. You can see a graph, and this is really cool, because dynamic table is derivative. It comes from a base table. And you can see this is your enriched customers. Well, where did that come from? It came from the customers base table. And the target lag for this is every minute this table gets updated based on the logic we've applied, reading from the base table. And you can see the refresh history. How often is this refreshing? Is it successful? What is the lag metric? Lag metric essentially tells you, are you running behind with the refresh schedule of your dynamic table? Usually you don't miss your lag metrics, but if you do miss that, that's something you might want to pay attention to. Every minute again, this will be getting updated. And I personally love this graph, right? It tells you the dependencies shifting to the left of what's happening within your dynamic table. And the same thing with filtered opportunities. If you take a look at the graph, you can see how this is being derived. Go to monitoring, dynamic tables. You can also see the history of your dynamic tables being refreshed depending on your schedule. You don't have to do it every minute the way I'm doing. You can do it every 5 minutes, every hour, or every day, depending on the schedule of your expected data coming in to your table. But dynamic table is declarative for keeping things up to date. Now go back into the exercise, continue to take the opportunities and the customers and join those together. We're going to create a new table called customer opportunities, essentially to see what opportunities are associated with which customers. This is something very common in analytics and sales. Now we have a new dynamic table. As before, step back to data, look at sales DB, look at that, do a quick refresh. We should have customer opportunities, view the graph. Now, customer opportunities is derived from enriched customer and filter customers, right? So, and this is really good to have a dark view, a graph view of this. Now you can visually see, if I zoom in for a second, you can see we have customer opportunities, which we've created by this script. And this looks at enriched customer that was recently created. And it also looks at filtered opportunities that was created to give us the customer opportunities. Very powerful. This shows us the derivations of where this data is coming from. Enriched customer gets updated every minute, and customer opportunities get updated every minute. You can build a really nice DAC, which is a directed acyclic graph with this using dynamic tables. Again, we can add some more aggregations to this. The sales, looking at the sales for every customer ID and summing that up. Something you might want to do, how profitable are particular customers. Now we're creating again another dynamic table that is derivative of the enriched customers and the filter customer. Go back and take a quick refresh of our DAC. Well, that refresh will manually refresh and process the data, but that's not what I want. What I want is we've created aggregated sales. Take a look at the DAC. Now you can see we have original base tables. These here are regular Snowflake tables, customer opportunities, enriched customer, and filtered opportunities. We've derived aggregated sales based on that, and you can see the derivative logic selecting on this. It highlights what tables are used for deriving this. If we look at customer opportunities, you see what tables are used for deriving that. Very powerful. And then next, we can keep going as much as you want to the nth degree. If you really want, you can make some complex DAX out of this for very complex and rich data transformations. Now, you can do this with streams and tasks in Snowflake. Anyone familiar with this? You can use streams and tasks, where the streams will identify your deltas and your changes, and then you have a task or a schedule that runs and applies those changes downstream to derive tables. What Dynamic Table provides for you is a unified way, a declarative way of getting to the same end result without a lot of code and maintenance needed on your part. Some folks will use materialized views for this, but the challenge with that is materialized views have some limitations with using one base table, whereas with like a dynamic table as such, you can join to as many tables as you want. There's a lot of considerations to decide if you should use a materialized view, a dynamic table, or streams and tasks, but Snowflake provides many options for you to pick from. Now, next, we've created that customer opportunities by sales. I think we've validated that customer opportunities. Oh, let's actually create this with sales. Customer opportunities with sales. I'm taking a look at this customer opportunities with sale. Query that for a second. Open up this customer opportunities with sale and do a select. Start from that table. We can see what records are in at the moment. We have 10 records. Pay attention to this. There are 10 records currently in this customer opportunities with sales. And if you check for any of the in between your derived tables upstream and count the number of records, they will all have 10 records. But if we go now with this script, now we are looking at dynamic tables in action. If you're following along with this lab, and insert some records into the customer table as well as the opportunities tables. I'm going to insert 1 customer records and 2 opportunities. This will be high value opportunities are being inserted, given the opportunity amount pretty high compared to what we have in the table. We've written a couple of select statements to take a look at the customer table with 10 records. We can see how everything flows through the system. Insert a new customer into our base table. At this point, the records are being added into customers. There are 10 records. And we should expect, we have 10 records. We have 10 records. And in customer opportunities, we currently have 10 records. Now, I'm going to insert 1 record into customers to see. Insert that. 1 record has been inserted. We should now do a refresh of our DAC. Do a quick manual refresh there. Takes a few seconds. We have 11 records, which is what we had. Those records should get propagated downstream with a lag of every minute. We have 11 records now showing up. We have 11 records showing up, and we have 11 records showing, right? That's the power of dynamic tables. You make a change to your base table, and based on the lag, everything downstream gets updated. The same thing applies to if we updated the opportunities, that we should expect that to flow through. If we inserted 2 new opportunities into the opportunities table, currently we have 12 opportunities. Manually refresh that and push everything downstream. 12 opportunities will filter in the opportunities. Now we have 8 because we've inserted 2 new high value opportunities, went from 6 to 8. Aggregated sales is 11. And then customer opportunities is 12. Those have changed accordingly. But just to give you the idea of how powerful dynamic tables are, you can do the same with inserting records with data quality issues and seeing how the system responds. If you remember, we had a filter for invalid stages. This should be caught, and this record should not propagate through the system. Even though we've inserted 3 new opportunities, we do the refresh, the invalid ones will not propagate. Try this out. Same thing applies if you update records on your customer table and your sales data. With changing the logic, you should also see this getting propagated downstream. Now, one thing that could be very powerful too is a visual way of seeing this all coming together. This is where there's a basic Streamlit app included as part of this lab to help you with that. If you want to get this Streamlit app running, simply copy this code. Obviously, you can make this improve. Go over to Streamlit, open up a new Streamlit app, create the Streamlit app. Again, I'm copying the code over from the Streamlit app, throw it into this. It takes a few seconds to run. Doesn't find a module called matplotlib that is expected. Go to packages, see your packages. Rerun that one more time. This took a few seconds. It's a basic Streamlit app to show dynamic tables in action. We have 11 records in the customers table, 15 in opportunities as of the moment, 11 in enriched customers, and these are the tables downstream that are all derivative based on these two base tables, customers and opportunities. At the end, we want to see what gets into customer opportunities with sales to give you a visual representation of the count of that. Now, I'll insert batches of records into our base tables. Right now, there are 11 records. Pay attention to that. Insert the first batch of new records. The batch of records have been inserted. We've inserted 3 records, and this should take about 45 seconds for this to get refreshed. All right, that refresh was completed. We now see the counts have increased from 11, I think we had, to 14, and every count downstream has also increased as well. And this is a good visual test to show you inserting records into your base table, dynamic tables. The dynamic nature of this keeps it up to date for you downstream, and you can keep testing this. I can insert more batches. Batch number 2, I think batch number 2 is a batch of records from, again, 3 records each. If I want this near real time, rerun the app. 17 records, and all my downstream tables have been updated visually. If you look at the base table, the logic associated with that too has all been applied. Very powerful. Lots of resources. There is the guide on dynamic tables, what declarative streaming processing is. This is really about streaming IoT data, sensor data, streaming in even down to minutes and even seconds. And you want to keep track of those changes, the deltas, and apply them downstream with complex business logic. What you're going to want to look at is dynamic tables, which is a very powerful option in Snowflake. The visuals for you to visually see what is happening in your dynamic tables with this DAG is also powerful. You can see the refresh history every time it runs visually to see what's happening in your dynamic tables and how successful it was, how long it took to execute. You can jump in and see the query profile. You can preview data at any point in time on your dynamic table, view columns, apply security procedures and masking policies, and all the things you can do on most tables. Apply those to your dynamic tables too as well. Hopefully this was helpful to you. Thanks for watching. Share this with somebody that might get value out of it. I'll see you in the next demo.